For this talk, I am talking about Office Online, both the on-prem and the cloud version, and integrating using WOPI and FSS HTTP, which are protocols that are in our open specifications and available for people to implement with. So first I wanted to just talk briefly about Office Online. Most of you know what Office Online is. You've seen it, you've worked with it. Basically, this is the way we access Office documents from anywhere with a lot of the common Office, powerful Office features. And a couple of things that are really great about it is it's got a lot of free options for using it, and it also includes co-authoring, editing, multi-user editing, and that kind of thing. And it's now, instead of calling this Office Web Apps as we used to, it's called Office Online. So I'm sure that most of you have seen that, and you know now office.com. This is recognizable here. So my name is Tom Jebo. So I am a senior escalation engineer in the Open Specifications Developer Support team. On my team, we interface directly with our customers and help them with any issues that they run into while they're implementing. So we have many different channels to do that. We work with them through email, phone, through our public forums, things like that. But our main goal is to make them successful with the tools and technologies that we create. Some of the editing features and features that make this very powerful, and which we'll now touch on with the WOPI protocol, which make that powerful, are multi-user authoring. These are available in Excel, OneNote, Word, and PowerPoint. Editing in document editing, change tracking, commenting. These are all collaboration. These are all features that are available through Office Online. Okay. And then just a note about Office Online itself. So Office Online is a server product. It's available for download for on-prem use as well as using it in the cloud. It sits separately, it deploys separately from all of these other products that it used to integrate more tightly with, which is good for administration and deployment and maintenance. Okay, so let's get into the WOPI protocol. The WOPI protocol, this is the Web Open Protocol interface. This is the one that the Office Online server uses to talk to the back end, which in most cases for us is SharePoint. It can also be Exchange and Link and some other ones. And because of the WOPI protocol and being in the open specifications, being publicly available, it can be your own file host. So here's a diagram that shows you what the architecture of this looks like. We have the end user sitting in the browser using the Office web apps. This would be Word Online, Excel Online, that kind of thing. And in a host frame that's provided by say in this case SharePoint, and then running these web apps inside. So the Office Online apps are the web apps that are interacting with the user. This is the editing, this is the document view that the user sees. And so the WOPI protocol is the part that sits in between SharePoint and Office Online Server, or Office Online Server and your own WOPI host, whatever the file host would be. And this is the one that allows them to communicate the contents of files, the locking of files, the co-authoring, and all this kind of thing. What I am discussing is integrating with Office Online. And what that means is if you have a file host, say a web-based file host or something that's analogous to something like SharePoint, it doesn't have to be, but it can be like that. And you want it to integrate with something like Word Online or Excel Online, and you want those applications to be able to reach the file host. There are protocols that you can use that are open and specified on the web, and you can implement those, and they're very straightforward. They're basically REST protocols. The WOPI protocols is what I'm talking about. So where is this? So this is in MS WOPI. This is in the MSDN open specifications. And it describes this communication between the WOPI client, which would be the web apps, the Office Online server, and the WOPI host, or WOPI server, which would be a file repository. And defines these set of operations we'll see in just a minute. It's REST-based protocol, so it's very easy to wrap your head around, very easy to use. And then it's an open specification, of course, so it's free to implement. And then, of course, I just described the rendering in the browser and then the file host side of this. And this is a diagram directly out of the open specifications. And this describes the interaction using the WOPI protocol between these three parts we just saw in the diagram earlier. So I won't go through that in detail, but the WOPI interoperability, I won't talk about open from you all, but developing your own WOPI host using the WOPI REST APIs and endpoints allows you to basically sit on the same level as SharePoint, OneDrive, Office 365. So for a WOPI host, if you are a file repository server or file repository application, the WOPI host basics here are these are the steps. Implement the WOPI endpoints, and there's some great help on the web for doing that. Readthedocs.org has a WOPI documentation site for this. Use the discovery XML that comes, discovery JSON that comes back from the Office Online server. And this is something, I think I've got this on one of the next slides. This describes all the actions that the Office Online server can take once embedded into your browser. And then build the host page, which is the thing that has the frame, and that frame is going to host the Office Online web apps. So these are the three basic steps you need to accomplish, and these are covered on the readthedocs.org reference site. Okay, and then here are the endpoints. Just list the endpoints. These are the basic operations that WOPI hosts will be doing. They'll be asked to do by the Office Online server. Check file info gets information about a file. Put relative file is how a file is moved from one, or copied or moved from one place to another. Locking, unlocking are the semantics used for actually causing or allowing multi-user edits and co-authoring. And then the execute cell storage request we'll look at in a little bit later when I talk about FSS HTTP, which is the file sync through SOAP, through the web, and then of course deleting. And then get file and put file are whole contents of files being uploaded and downloaded between the WOPI host and client. And so that's generally the method without using the execute cell storage request. That's generally the method that WOPI uses to store and put files between those two. This is the discovery file. So the WOPI client, the Office Online server, will publish this file. You can get to it directly from this URL hosting discovery. And it has JSON that has all of the actions. And then the WOPI host takes these actions, all of these URLs in here, and plugs them into its host page as links for different files that it has hosted on the server. And so then the WOPI host allows the user, the end user, to click on these, and that's what brings up the experience, the Word, Excel, PowerPoint Online experience. And as you can see, this is what these look like. And then there are replacement parameters that have to be changed by the WOPI host once it uses, or before it uses these in the host page. And those replacement parameters, fill in the actual file and file ID and things to be edited there. Okay. And there's the section within the document that talks about discovery. Okay, so for co-authoring, these are the important endpoints to be implemented: locking, unlocking, check file, and put file. These are the ones that happen. Basically what happens is the Office Online server takes care of all of the behind the scenes of co-authoring and multiple editing. And so the file is locked, but the multiple users in the browsers don't really have to know anything about that. And then the Office Online Server does frequent put files of the entire file. It does them every 30 seconds or so. And then it just uses the last user that was that made the last edit as the one for that particular put file. The web app does take care of change tracking and all that, so you don't lose that functionality, but you still get the co-authoring and multiple editing. So it's not as fine-grained as FSS HTTP, but it gives you the functionality without having to go into like 6 months to a year worth of implementation. So in previous versions, you would have to do, in check file info, you'd have to return a parameter called supports Cobalt, and then implement this entire FSS HTTP in your WOPI host. Okay. And then there is an implementation sample that you can start out with if you're building a WOPI host. And this implementation sample is on GitHub. You can download it, build it, and start out from there, and then just start filling out the various handler functions. So these are just some message analyzer screenshots showing you what the traffic looks like for WOPI. And you can see the get files in there, the locks, and get check file info, lock, get file requests. This is very simple traffic. Okay, so we'll move on to FSS HTTP, and I'll just do a very brief, quick overview here. This is a highly complex protocol, and it allows implementers to do a much more fine-grained, efficient sort of synchronization on the web. It's web-based, it's HTTP-based, but it's a much more complex protocol. And I am touching on this protocol as well. FSS HTTP is the file synchronization and sharing over SOAP. It's the fine-grained synchronization that we do when we're doing co-authoring. And it allows for, basically, it allowed us to go from something like WebDAV, but go one step further and have much more efficient, high-frequency incremental syncs without sending too much data over the web. And then it gave the sort of rich locking semantics, exclusive and shared locking called schema locking, and then also allows for metadata to go along with the file. Okay, so FSS HTTP is a SOAP-based packaging of binary data that goes and updates little bits of the file at a time, not the whole file, only the things that have changed recently. This can be wrapped within the WOPI execute cell storage request. It can also be sent independently as just SOAP requests. And that happens with the desktop clients. So here are the main documents. FSS HTTP describes the wrapping SOAP requests. FSS HTTP-B describes the binary requests. These are the individual cells and parts of the documents that are being changed, only that are being changed for the incremental change. And then D describes the schema that document formats can use to break down their files so that they fit into the structures that we'll see in just a minute. Okay, so we have a model here, just briefly, object graph or object model and storage graph model. These are just conceptual over the document format or the document cells and bits and pieces that get sent in that B part, in that binary part. The object graph is kind of what the application sees and the client application sees, and then that gets translated into the cell request, which is the storage graph. The cell request allows us to create this nice graph with immutable data elements and then mutable index elements so that when a change is made, we can just replace an entire node and fill in the new data element. And then we've also got this ability to track these changes. So here's where these pieces sit in the documents. FSS HTTP describes both of these layers of storage in the object graph. And then D describes the document schema layer that breaks down the file into efficient chunks so that they can then be represented in the object graph. So just a quick sort of, this is what it looks like when FSS HTTP-B is going across the wire. We start out with a document represented sort of theoretically like this, the cat sat, and we have index nodes. The data element nodes are immutable, so they never change. The index nodes can change to change the structure of the graph. This would be a whole file, and this would be sent to the client by the WOPI host to say, here's the initial state of the file. If a change is made on the, that was made by another user on the server or something, so now a new node is inserted. Now the client needs to know about this. The client can get changes or query changes, and then the client receives just the things that change, so it can now update its graph and know what the current state of the file is. And again, this then translates into the internal representation, which would be the storage graph inside the client application. So this is, I know this is a very like high level and sketchy, but basically that's what happens in the B document in the binary representation. So that's how we get the efficiency and sort of the small data amount that's getting transferred back and forth. And then this is just representing what happens in the D document. This is the schema, and this is how, for general files, we can break down the file into chunks and then translate that into that storage graph. And we have different ones for one note, and then ones for other ones. So basically, what happens in the D schema is that we have a compression algorithm that will break down the file based on sort of intelligence, like paragraphs and things, and then represent that in a graph so that those parts that are likely to change and can be represented in data elements, and the parts that are less likely to change can be chunked together. Okay. So this is just a typical scenario. But this actually represents just the locking side of it. It doesn't represent the full, so what we see is an exclusive lock and the server transferring these back and forth. This is actually not a good diagram for the full sync. So yeah, sorry, that was a very sketchy overview, and I had to cut a lot of slides out. But if you are working with FSS HTTP, or you need to be working with it, definitely send us an email at dochelp@microsoft.com, because we can certainly direct you. The FSS HTTP documents are very complex. The protocol itself is fairly complex, and we can definitely help you and guide you. We try to discourage, not discourage people from using it, but try to use a simpler and more straightforward approach. So if you can use like Office Online, and you can use WOPI and use its multi-user editing and co-authoring, that would be a best case scenario. If not, there are other avenues to help you implement this. Okay, and then here's some of the available resources for Office Online and WOPI. And that's it. What I expect from this conference is to see what people are doing with these technologies and to talk to them, to see what kind of issues they're running into it, because this is what I take away from it. I go back to my team and kind of prep them and say, look, this is what our customers are hitting, and this is what we need to work on, and this is what we need to do to make these technologies better and help them.